So things get a little complicated a little quickly here. But before we begin with talking about multiple of the same factor, let's go back to the solution here. So I left it saying that, hey, you could check this on Wolfram if you want, but let's go through how we would actually do this. So this is going to be our common denominator. And I'm thinking, if I'm looking at this denominator here, I need to include the other two factors as part of my fraction. So for a, I'm going to multiply by x minus 5 and x minus 2 on top and on bottom. Now similarly with b, I have x minus 5, but I'm missing x and x minus 2. So really, this is just finding common denominators. With x minus 2, I'm missing an x and an x minus 5. Okay. Now, at this point, when you're setting up equations, you can actually ignore the denominator because it's a big common denominator. Kind of like if you had x plus 2 all over 1 plus 2 equals 5 over 2. You don't have to think about the 2's to be figuring out what the solution is. You just think what plus 1 is 5. So I'm going to write it out here. Negative 3x squared minus 8x plus 10. And I always write a and FOIL out the rest separately before I distribute it in the a. So this would be minus 7x plus 10. This would be x squared minus 2x. And this will be x squared minus 5x. Alright, take a moment to write this all out with our letters distributed. And this is going to be a minus 2bx. Okay, a lot of writing. And at this point, we can start setting up our system. So for x squareds, I actually have 3 of those. So it's going to be a plus b plus c is negative 3. Alright, and then we look at our normal numbers next to x's. So this is going to be negative 7a plus negative 2b plus negative 5c should give me negative 8. And then let's look at the plain numbers. So I have 10 here, and I have 10a right there. So 10a equals 10. Alright, now that last part is really nice because I can just solve that and get, well, a is 1. So I'm going to take this entire system here and I'm going to plug 1 in here. And then I'm going to think about this. If I have 1 plus b plus c equals negative 3, really it's b plus c equals negative 4. I'm subtracting the 1 over. Similarly, if I have negative 7 plus negative 2b plus negative 5c equals negative 8, I can add 7 on both sides. So this is going to be negative 2b minus 5c. And if I add the 7 over, I get negative 1. Alright, now originally, when I get equations like this, systems, I would normally do elimination, but in this case, if I add down, I have no canceling. So what I can do, though, a trick we learned from advanced algebra or algebra 1 is we can multiply by 2 everything. What this does is it creates a system where the b's are going to cancel. And this is completely legal as long as you multiply everything on the row by the same number. So let's add down here. We have nothing. These eliminate. This is going to be negative 3c, and this is going to be negative 9. So c is 3. Alright, a is 1, c is 3. And I can actually plug this in wherever I want in these systems. So I'm actually going to do b plus 3 equals negative 4. So actually b should be negative 7. Whew! It's a lot of work, but we have our answer. We have 1 goes over x, negative 7 goes over x minus 5, and 3 goes over x minus 2. All right, so that was a quick rundown on that problem. There is an issue, though, that comes up in which you have multiple of the same factor, and you have to change what you're doing. So, I have an example prepared here for you guys. It's negative x cubed plus 3x plus 3. And now we have x cubed minus 2x squared plus x. I start by factoring the bottom so that I can tell what my fractions have to be. If I pull out a GCF, I get x squared minus 2x plus 1, and that factors more to be x minus 1, x minus 1. So here's the weird thing. If you start setting up partial fractions, well, you would have 2 of the same factor as a denominator. Something's wrong with that. So what I compare it to often is with normal fractions. Say you have 1/6. The factors of 6 are 2 and 3. And so if I want to combine fractions together to make a 1/6, I need to have something over 2 and something over 3. And after some investigation, you might find that this works. And yes, this would be 3/6 minus 2/6, which would be 1/6. But this won't happen if you have multiple factors. So for example, you have 2 times 2 is 4. If you just stick with 2 and 2, you're never going to make a combination of halves that will equal 1/4. So what you have to do is consider 1 2, and then both 2's are 2 squared. So if we change that 2 squared into a 4, you could think 1 minus 1/4 is a 4th, and then we can have some combinations that work. So similarly here, if we have x and x minus 1, we are going to include one where we do both of the doubles. Alright, so now let's find a common denominator. Actually, by the way, if you had something like x minus 1 3 times, you would include x minus 1, you'd include x minus 1 squared, and you'd also have another one with x minus 1 cubed. It'd be a lot of work. So, we're missing x minus 1 and x minus 1 on top and on bottom here. So I'm just going to draw an arrow. Here we're missing x and x minus 1 because we already have one of them, and same down here. Up here we're just missing an x over x. So now we have common denominators all the way across. Let's write this out. And again, I FOIL this out and I leave my a out normally. Okay, let's drop our variables in. Oh, and I'm sorry, we have to make sure that these are all squares. I keep writing cubes. So this should be squared, 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 squared. All right, and then I'm going to start highlighting things that go together, like negative x squared, ax squared, bx squared. In our system, we're going to be writing a and b equals negative 1. Okay, now for x's, so that and that and that, which turns out to be negative 2a minus b equals, oh, and I'm sorry, I didn't highlight the last one here, so really this is going to also be plus c equals 3. Now the last ones that weren't highlighted are our last terms. It's just saying, hey, a is 3. That's nice. Okay, well, if we know a is 3, we can plug it in the top. This would be 3 plus b equals negative 1. So b is negative 4. And then I'm going to take both of these and plug them both into this middle equation. So negative 2 times a minus b. So this is negative 6 plus 4 plus c equals 3. Negative 2 plus c equals 3. So c is going to be 5. All right. Now let's write this answer out. It will be okay. That is our partial fraction decomposition. One other thing that people will often ask is, well, couldn't we write minus 4 over that? And the answer is absolutely yes. But when you do the setup, just always include pluses in between, because you can't tell which ones are going to be positive and which ones are going to be negative right away.